Okay, guys, what we're going to look at now is one more index law, all right? There is another one, okay, but I don't want you to worry about the other one for the moment. Now, this video will be a little bit longer because there's a few things I want to show you with this one. So powers with a negative exponent, all right? What I want to first start off with is I want to go through one of the previous rules with you, and then we're going to show you how this works, okay? So if we have x to the power of 3 divided by x to the power of 5. What does that mean? Okay, now you guys know from the previous index law that that is the same as x to the power of, and let's think about it, we had a to the power of m divided by a to the power of n. Remember, the bases are the same, and that was equal to a to the power of m minus n. So let's have a look. So we get x to the power of 3 minus 5, which is x to the power of minus 2. All right? So this is one way that we can look at this question. Okay? Now there's another way we can also look at it. I want to look at this the long way now, and that's by writing it out. Okay? So this is also equal to x cubed on the top, so x multiplied by x over x to the power of 5 on the bottom. So we're going to do it 5 times 1, 2, 3, 4, 5, multiplying in between all of these. Okay, we know that we can cancel these out and replace them with 1s because x divided by x is 1. So let's do that 3 times here. And what do we have left? So on the top, we've got 1 times 1 times 1, so we have 1 divided by. On the bottom, we have x times x, so we have x squared. All right, so we've just done the same question in 2 different ways, and we've gotten 2 different answers. Okay, but both questions started out with this part here. Okay, both of them started with this part here, yet we got 2 different answers. We got the answer of x to the power of minus 2. Okay, so that was one answer that we got, but we also got the answer of 1 over x squared. So which one is correct? Okay, actually they both are. And this is what we're trying to show here, which is that x to the power of minus 2, x to the power of minus 2 is equal to 1 over x squared. All right, so if you have a negative power up here, what you can do is you can move it to the denominator, okay, and make the power positive. All right, so when you move this to the denominator, you have to think about what gets left behind. Okay, this is really 1 times x to the power of minus 2. All right, so when you move that x to the minus 2 to the denominator, okay, that 1 stays in the numerator. Okay, so it ends up that that 1 stays behind, and the x, and we change the power to positive, goes down the bottom. All right, so this is not very difficult, but to start off with, people find it a little bit strange. All right, I want to go through a few examples of how this works, and we also need to look at a reverse example. Okay, so we'll do that as well. So basically, if you have things on the top, so let's say we have 2a squared b to the minus 3c. Okay, now you can see here that b to the power of minus 3, that's got a negative exponent. The rest of it doesn't. You have to remember that the index only belongs to the letter or the number that it's attached to. It doesn't actually belong to anything else. So that b is the only thing we're going to change here. Now we said that that variable that has the negative has to move to the denominator. So, and anything else gets left behind. So what's left behind is what I didn't highlight. So the 2a squared c, that's going to stay where it is, and we're going to divide that by b, and we make the power now positive, so it becomes b cubed. And that's it. That's our answer. All right, now so basically, if you see a negative exponent in the top, move it to the bottom, change it to a positive exponent. That's all we do. All right, now there is one more thing that we need to look at here. And that's actually that sometimes your x to the power of minus 2 might be on the bottom. So for example, if we had 1 over x to the power of minus 2, okay, what do? Because we don't like these negative exponents. We don't want them to be there. We want them to be positive, okay, because a negative exponent doesn't really mean anything to us, okay? We want to make that positive. Now, without going into too many details about this, basically in this case, what we actually do is we actually move the variable that has the negative power attached, we move it to the top, okay, and we make the power positive. Alright, so the reverse works exactly the same way. If you have something with a negative exponent on the bottom, you just move it to the top and change the power to positive. Alright, so let's have a closer look at this. If I have something like 4a squared over b to the power of minus 3, let's keep it easy. Okay, you can see again that b to the power of minus 3 is a negative exponent. We don't want that. We want it to be positive. So what we're going to do is we're going to move it from the position it's in up to the top. So it's going to move up to where this 4a squared is. We're going to put the b up here as well, and we're going to change the power to a positive. All right. Now what was on the bottom? There was really a 1 there. It was really 1 times b to the power of minus 3. And we don't usually bother writing divided by 1, okay? So we can just leave it like this. This is done. Now it gets a little more complicated sometimes if we have more things going on. So let's say we have 5, a to the power of minus 2, b squared, c to the power of minus 1, divided by 2, a, b cubed, c to the power of minus 4. Okay? Now what happens here is we have a few things that are going to move. So what I want you to do is start by identifying what's negative, okay? So we know that on the top we have this one is negative and this one is negative. So they're going to move to the bottom and the rest is going to stay. So what we're going to do is we're going to keep 5b squared because that's what's left. And we're going to draw our line here, the dividing line, okay? Now, we're going to move that a to the minus 2 down. So we're going to put it as a squared. We have to make the power positive. And we're going to move the c to the bottom as well. So this becomes just c. We're not going to write the 1. You don't need to write it. Okay, maybe before we finalize the question we will, just so you remember. But we're not going to write it by the end. Okay, we don't write those ones. Now we need to look at the denominator because there's more going on here. Because we also have a negative power here, but the rest is a positive power. Okay, so the 2ab cubed is going to stay at the bottom. So times 2ab cubed, that stays there. And that negative power moves to the top. So that's c to the power of now positive 4. Okay, so this needs a lot of cleaning up. Firstly, we're just going to clean it up by putting things in order. Then we're going to look a bit more closely. So 5b squared c4, we can't do anything there. Okay, we always put the coefficient at the start. Okay, so we always have to have the coefficient at the start, which means that 2 needs to move to the start. Okay, and remember we always put our variables in alphabetical order. Now we have a squared times a. So remember there's a secret little 1 here that we don't write. So this is going to become a squared times a is a cubed, okay, because we have to add those powers together. Now we look at the b's, so we just have b cubed, that's fine. And then we have c to the power of 1, or just c. So we're almost there, because at this point now we need to simplify. And of course we could have simplified back at the beginning, okay, but this is more about the practicing. Okay, so we know the 5 over 2 doesn't change, it's just going to stay as a 5. Now we have b squared divided by b cubed. Okay, you can either sit here and calculate it, or you should be able to see that if we cancel some of these out, let's actually write this out the longer way. Yeah, we could do that. So let's let's just, use your brains here. So we have b times b and c to the power of 4. Okay, once you get better at this, you won't worry about doing any of this anymore. And then we have a cubed, because we know there's no more a's, so we don't need to worry about that one. B cubed, so 1, 2, 3, and then c. So now we've got some things we can cancel here. We can cancel 2 of the b's, we can cancel 1 of the c's. So what's left behind, and this was an awkward way of doing it, but that's okay, is 5 c cubed over 2a cubed b. Alright? Now there are different ways of approaching these. You could have done it in about 4 different ways. This is just one way, okay? As long as you follow all your rules correctly, you're not making up things that don't exist. And as long as everything's clear, then it's okay if you do them in a different order. But this is the kind of thing you need to be able to do with these questions. Okay, one more last thing just to make it a little more of a fun trick for you. If we have something like 2/3 to the power of -1. Okay, now we discussed in the past that means we have, remember you have to apply that -1 to everything inside the brackets. So it's 2 to the -1 over 3 to the -1. But 2 to the power of -1 means we need to move it to the bottom and make it positive. And 3 to the -1 on the bottom means we move it to the top and make it positive. And what you should be able to see here is that 2/3 has flipped. Okay, so if you have a negative power, what you can actually do is just flip it and make the power positive if it's a fraction. So for example, if we have x squared over y cubed, and we have that raised to the power of -2, for example, because it's a -2, we're going to flip it. So we're going to put y on the top and x on the bottom. So what was y cubed and x squared, and we're going to make that power now positive. Okay, so our power is now positive. We flipped our fraction or our quotient. Okay, now we can apply the squared to both. So it's going to be y to the power of 3 times 2 over x to the power of 2 times 2, which is y to the power of 6 over x to the power of 4. Okay, that's a nice little trick for you as well if you see a fraction raised to a negative power. As I said, it was a bit of a longer video, but that's because there's quite a few things in this one. Okay, good luck.